Hello everyone. Today I will continue talking about polymer chemistry. In specific, we will talk about one type of polymerization, which is the free radical addition polymerization. Now, from the previous video, you know that there are two types of polymerization: the chain growth polymerization, or what we call it addition polymerization, and the condensation polymerization. This video will focus on the free radical addition polymerization as one type of the chain growth polymerization. You could see that there are another two types, which is the cationic polymerization and the anionic polymerization as well. Now, free radical polymerization is, or what we call it, free radical addition polymerization, is a subcategory of the chain growth polymerization. From the name, you could see that we will form a free radical that will attack a double bond and forms a longer radical. Now, in the addition polymerization, usually the polymer is a repeating unit of the monomers. Now, for the free radical addition polymerization, the free radical addition reaction would occur in three steps: the chain initiation, then the step number 2 would be the chain propagation, and the last step would be the chain termination. Let's start first by looking at the chain initiation step. The chain initiation step, at this step, the composition of my initiator will happen due to a thermal initiation or photo initiation, or even radiation initiation that will break my initiator into two radicals, and these two radicals are either homolytic or heterolytic. What we mean by the hemolytic or heterolytic fission of your initiator into those two radicals, in the heterolytic fission, when you break the bond between the two initiators, one of them will take the two electrons of the bond and will carry a negative charge, or one of them will not carry, will give away these two electrons and will carry a positive charge. This will happen when you have the heterolytic fission. But if you have hemolytic fission, each one of them will carry only one electron, and those are my radicals. Now, the chain propagation step. Usually what happens, you have these free radicals that will attack your double bond, your monomer, and will form a longer chain. So first step, this radical would attack the first monomer to form a monomeric radicals. Those monomeric radicals further attack another double bond to form a dimeric radicals. Then it starts to grow again by attacking, so this one would attack another double bond and form trimeric radicals, then tetrameric radical, and so on, until you have this long chain of radical. And this radical, because I have here the radical, will attack another double bond and will have this polymer radical, and we name it in that case the living polymer. We name it the living polymer because it's like it is growing. The last step is the chain termination step. The chain termination step can happen either through a coupling reaction, or dispropagation reaction, or chain transfer reaction. Let's look at the coupling reaction. Your polymeric radical would just attack another long polymeric radical, and both of them will just form what we call dead polymer. This dead polymer means it's not growing anymore. Both radicals will just form between a bond between each other, and this bond will prevent it from growing further. Another way of the chain termination is through the dispropagation reaction. The dispropagation reaction is similar to the coupling reaction, but you will have this radical. So your polymeric radical would just react with another polymeric radical, but they will form another, and then they will form a bond between a double bond, unsaturated polymeric radical, and your long polymeric radical. This will stop it from growing further, and this recombination by radical is through what we call it the dispropagation, would form a chain with unsaturated bonds to your chain. Now, the chain transfer reaction as the last way of the termination reaction can happen either through the transfer to monomer or transfer to polymer or transfer to solvent as well. Let's look at the chain transfer reaction when it happens transfer to monomer. This means one of my monomers which carries a double bond will give away one of its proton to my growing chain, and this will stop my growing chain from growing further. Or either transfer to polymers. This is the second method, the transfer to polymer. And in that case, when it transfers to polymer, what will happen is actually one of the living polymers will give away one of the hydrogens on one of the side chains. And this hydrogen will just stop my living polymer from growing further. And because here will miss one electrons, it will react with another monomer and form branched chain. This is very important when we try to form what we call polyethylene polymers, because the polyethylene density will depend on the amount of the chain transfer that would happen, because you will have these chains, side chains. Now the transfer to solvent, this means most of the time we should not use any solvent that can interact with my polymers, but sometimes the solvent is not inert anymore and it will give away one of its proton to my growing chain, and when it happens my polymer will stop growing and and the solvent will just cause my polymer to form oligomers. Now, for the chain initiation, we said that we need initiator in the free radical polymerization, and for that, here are some few types of the initiators that we can use, and the type of initiation we can use to initiate or to form radicals from those initiators. The first method of forming initiators is through the thermal decomposition, and for the thermal decomposition, usually it happens, hemolytic cleavage happens, and what will happen is just a breaking of a bond between two of my initiators into each one of them will have one electron. So the hemolytic, this means the bond will break and each one of them will have two radicals, which each one of them carries one electrons. This happens usually with the organic peroxide or azo compounds, like in here. You could see that the bond between the two oxygen would break and each one of them will take away one of the electron of the bond. Now, the third method for the formation of the initiators is the Redux initiators, and we could see that it will be a hemolytic fission that will happen for my initiator, and I will have one of them carrying a negative charge and the other one will lose one of the electrons and will carry a radical. Now, this happens usually with hydrogen peroxides, and we usually reduce them through using iron-iron or chromium, vanadium, titanium, cobalt. Also, copper can be used. In case of using iron, in that case, you could see that the hydrogen peroxide would oxidize the iron from 2 to 3. And now you have this hydroxyl ion, which carries a negative charge, and I have here OH, which carries a radical. So the fourth method in the formation of the initiators is through the pair sulfates. The pair sulfates, we will use the pair sulfate. Hydrophobic diffusion will happen through the dissolving of the pair sulfates in water, and this will allow it to form ions, and from these ions it will form a radical, and this radical will be hydrophobic, that can be used in that case in the emulsion polymerization. One of the radiation can be used in that case for the initiation. You could see that in here I have the initiator, and once it is hit by a beam of the radiation, it will form this positive ion, and this positive ion and give away one of the electrons. This positive ion, when it is further dissociate, it will dissociate into two particles. One of them will be the radical, and the other one will be the positive charge. Will carry the positive charge, and this positive charge usually go back and recombine with your electron that was lost from the first step, and you will end up by only the radical. The last method for the initiation is through the electrolysis, and this usually used with a coating metal surface with polymer film. And you could see that electrolysis would happen through the metal electrolyte. So we will use a metal electrolyte for the transfer of the electrons, and we will form a radical by losing one electron. So I will have this double bond that will take one of the electrons to form the negative radical, or in the first step actually what will happen, a breaking of this double bond to form the positive radical, or what we call the cation radical. So I have the cation radical losing one electron, then another monomer will take this electron to further form the anion radical. So the formation in that case, we don't use initiator. Instead, we will use the monomer for the initiation of the reaction. By that, we came to the last part of the free radical polymerization. In the next video, we will start talking about the ionic polymerization. Thank you and goodbye.